Welcome to springlib.
This question asks which of these compounds is the strongest acid. And so one way that we can measure acidity is by looking at the stability of the conjugate base. So we're going to draw the conjugate base for each one of these structures and then look at the stability of each one. So if we had a conjugate base for this first structure, let's copy that over. Okay, so for this first one, these are still here, and then let's put the lone pair right here so that it can interact with the pi system. So here, if I were to have this conjugate base, I could push this in here and push this up onto here, which would give me a resonance form that would look like this. So now there's a lone pair here. This is my negative now. This is up here. This is up here. And so this is the resonance form that we can get. And we can keep moving that around the ring if we want to, but that's not really going to change anything. What I want to look at here is the ring. So this ring has 4 electrons in it, which means that it is anti-aromatic. It's anti-aromatic because it follows all the aromaticity rules except for the number of electrons. It has a 4n number of electrons instead of 4n plus 2, which makes it anti-aromatic, which is not stable. If we go to the second compound here, if we had the conjugate base of this one, we would have a lone pair on one of these carbons down here. This we can move like this, and push this into the ring like that, and that would give us a resonance form that looks like this. So now this is my negative, and I have this over here. So now this one has 6 electrons in the ring, which is a 4n plus 2 number, and this is aromatic. So this one has a resonance form that is aromatic, making it very stable. If we look at the third one, let's say that I pulled the hydrogen off. Well, it could come off here or here. If it came off of here, then we would have 4 electrons in the ring again, like we did in the first one. That would be anti-aromatic. If it came off of here, let's draw that and find out what would happen. So if I pulled it off of here, this is my negative, then I could move this to here and push this to here, and then that would give me a resonance form that would look like this. So this is still here. And now I have a lone pair here and my double bond here. So this also has 4 electrons in its ring no matter where you take it off, either here or here. Which means that this is also, actually this one is non-aromatic, not anti-aromatic, because it has an sp3 carbon in the ring right here. So this one is non-aromatic in its resonance contributors. So like I said before, the one with the most stable conjugate base is going to be the strongest acid because it's easiest to form that base because it's the most stable. So that means that this one is going to be the strongest acid because we form this aromatic ring in our conjugate base.